Good morning. In this video, I'll be detailing about the assessment 1. So let's go into the discussion now. So for the assessment 1, we have been asked to predict a data model that predicts the electrical energy output of the combined cycle power plants. And we've been given a data set that has 5 columns, including temperature, pressure, humidity, and exhaust vacuum and energy output. So we have been asked to come up with a model that is able to predict the combined cycle power output. So that's the objective of this assessment. So we'll now go in detail to understand the various sections that have been questions and sections that have been asked related to this assessment. So let's go to the item number 1. So we've been asked to, in this case, we've been asked to determine the type of machine learning model that we use and what will be the output parameters that we will be using to evaluate the performance of the task. So in this case, since the electrical energy output is a continuous variable, we'll be going for a regression-based model. And for the output parameter, we'll be using, in order to measure the output parameter, we'll be measuring the root mean square error. So since this is the appropriate metrics to evaluate the model's performance, and it provides a measure of how well the model predicts the targeted value by quantifying the average magnitude of the errors. So that's why we use RMSE. I've also used mean observed error. Further, the second question we've been asked to identify the features and the algorithm that we'll be using. If you consider the data set, input data set, so we have 4 input parameters that we can consider, which is temperature, pressure, relative humidity, and exhaust vacuum. Using this, we will be able to come up with the predictions. And coming to the algorithm that we will be using, so we will be using regression-based algorithm. So we will either use a linear regressor, decision tree regressor, or a random forest regressor. So in this, for my case, I've used both decision tree and random forest regressor. And based on the, I think we can go to the inference after seeing the slide number 5. So we'll move on to the next section. So in this section, we've been asked, question number 3, we've been asked, how do we split the data and the validation strategy? So we'll be using the scikit-learn function that is available in Python to split the data into training set, validation set, and test set. So we'll be separating 60% for the training set, 20% for the validation set, and 20% for the test set. And for the validation, we'll be using k-fold cross-section to assess the model's performance. So coming to the model, I think we've been asked to use any validation approach and compare 2 different models. So for this case, we have chosen, I have chosen decision tree regressor and random forest regressor. And we'll be comparing the output of these 2 regressors. And the output metrics that we'll be using is both RMSE and MAE, root mean square error and mean absolute error. And using this, we will be able to try to see which one performs better. So I've come up with a small Python program to evaluate, to get the input. We invoked Python libraries like pandas and NumPy. I also invoked scikit-learn. And using that, I've also got the input data set and separated that input data set into training, validation, and test sets. Further, I've invoked random forest and decision tree regressors and tried fitting a model on the training data and also come up with predictive prediction model prediction. Further down the line, I have also come up with the values for RMSE and MAE. So, sorry, I have not come up with MAE here, so it's more RMSE. So that's, since that will show the right metrics. As we discussed before, we'll go for the root mean square error comparison between the random forest model and the decision tree model. So if we see here, we'll go to the subsequent last question and see the evaluate the performance of the model. So once we have come up with the Python program, now it's time to understand the come up with an inference based on the output metrics. So once the model is selected, assess its performance using the test set. We are going to do that, and we are going to, as we discussed before, we are going to calculate the MAE and RMSE to quantify the model's accuracy. Okay, and so using the Python program that I've done earlier, so I'll come up with the values for RMSE and MAE. So again, this shows just the RMSE alone. So in this case, I've chosen two algorithms, two algorithms. One is a random forest RMSE and the decision tree RMSE. From this, you'll be able to understand that random forest performs better, and you'll be able to use that to arrive at a better accuracy than decision tree. So with this, I'm going to end my assessment video. Thank you. Thanks a lot.